All right, hey gang, we are going to start to take a look at inequalities involving absolute values. I'm just going to rattle off some stuff here, and if you have any questions, come back and talk to me. But a lot of this stuff points back to what we've been talking about this chapter, but also what we talked about back in what was it, chapter 3, I think 2, 3. So let me get right into it. So let's take a look. So to start off with today, remember the definition of an absolute value is the distance from zero. And so when we talked about this a long time ago, like I said, chapters 2 or 3, we would do something like this. The absolute value of x is equal to 2. So what do we know? Well, either x is equal to 2 or negative 2. So we would just do plus or minus 2, okay? 2 or negative 2. Because if I plug in 2 here, the absolute value of that still gives me 2. If I plug in a negative 2 here, I still get an absolute value of 2, okay? So again, just reviewing what the absolute value means. Now, as far as these symbols, the inequalities, how does that play out? I'll talk more about that in a second. But what I need you to understand is that if we have a greater than, or a greater than or equal to, we're going to refer to that as an or statement. Okay, and I'll explain what that means here in just a moment. If we have a less than or equal to, we're going to refer to that as an and statement. Okay, so just keep that in mind as I go through these problems here. So starting with number 1, match the open sentence with the graph of its solution set. Well, maybe we should come back to this, actually, now that I think about it. Let's actually go down here to these problems, number 7 through 10, and just make sure we're okay with solving something like this. So the first thing I look at is the fact that I have a less than symbol, which means I'm going to have an and statement. So here's what I'm going to do. I'm going to go ahead and do x plus 1 is less than 0, and this is an and symbol right there. It looks like an A, almost like an A. And then I'm going to do the same first part of the expression, x plus 1, and I'm going to flip it, and I'll make this number the opposite value. Now, the thing is can I make 0 an opposite value? The answer is no, okay? So if I go ahead and do this, okay, and I go ahead and solve both of these, okay, let's see here. I would have this, subtracting 1, and subtracting 1. Okay, and so what I know is that x is going to be less than negative 1 and x is going to be greater than negative 1. Now as we do that, thinking about how that would play out, okay, I probably shouldn't have started with this one because it could be a little tricky, but here's what it is. I have an open circle on negative 1, everything to the right. And I have an open circle on negative 1 and everything to the left. Now, what does it mean to be an and statement? An and statement is where they overlap. Where do they come together and where they overlap? Is there any parts of these two graphs, these two equations, that overlap each other? And the answer is no. And so as a result, my answer for this problem is going to be no solution. Okay, there is no value that I can plug in here and I can get a value of less than 0. Now we should have probably known this because let's be honest, the absolute value of any number has to be a positive number, right? And so as a result, is there any way I can get a negative value because it's got to be less than 0? And the answer is no. So we probably should have known that before we even set everything up, okay? All right, now as I look at number 8, again, we have a less than symbol, so I'm going to go ahead and do c minus 3 is less than 1, and c minus 3 is greater than negative 1. Notice how I made that the opposite and the opposite there. This entire part becomes the opposite value, okay? Now, as we work this out, I'm going to add 3 to both sides. This becomes 4. Add 3 to both sides. This becomes 2. Okay, 3 plus negative 1 is 2. Now, if I graph both of these, c is greater than 2, like that, and I have c is less than 4. like that, okay? Now, where do these two inequalities overlap? These two graphs overlap. They overlap from here to here. So as a result, my answer is actually going to be an open circle on 2 and an open circle on 4 and everything in between. These right here, I can go ahead and get rid of those. They no longer are needed. This is my answer. Now, if you think about it, I can choose any value between these two, and it would satisfy this inequality. So let's say I choose 2.5. Okay, 2.5. If I plug that in up here, the absolute value of 2.5 minus 3 is less than 1. 2.5 minus 3 is negative 0.5. And the absolute value of negative 0.5 is 0.5. Is 0.5 less than 1? Oh, went off the screen there. Is 0.5 less than 1? It is, okay? Now let's say, for example, that you decide to use a number from this inequality where it continued to go on this direction. So let's say I put in like a 7. If I was to use 7, the absolute value of 4 becomes 4. Is 4 less than 1? And the answer is no. Okay? So again, when you have a less than symbol, it's an and statement. And. Okay? As I look at the next one, I have an or statement. So if I work this through, I have n plus 2 is greater than or equal to 1. Or, and I'll explain what that means here in a second. Notice the symbol, or n plus 2 is less than or equal to negative 1. Okay? Now, from here, let's see here. I'm going to go ahead and subtract 2 from both sides. Okay? Subtracting 2 from both sides. Now, this one says n is greater than or equal to negative 1. So I'm going to close that circle in. Greater than or equal to. Okay. This one, less than or equal to negative 3. Okay. And so being an or statement, and this is really important, an and statement is where they come together, okay? Where they overlap each other. An or statement could be one or the other, okay? Either one of those. And so as a result, as I look down at our worksheet here, what I'm seeing is this. My solution could come from this inequality, or it could come from that inequality. Let's just kind of test that here. Let's say I use 0 from this one. Okay, if I do absolute value of 0 plus 2 is greater than or equal to 1, I have the absolute value of 2 greater than or equal to 1. That means 2 is greater than or equal to 1. This is true. Check. Okay, I'd be using 2. Let's say I use negative 5 down here for the other one. Absolute value of negative 5 plus 2 is greater than or equal to 1. We have an absolute value of negative 3 greater than or equal to 1. That makes 3 greater than or equal to 1. That is true. Okay. So again, I can use any number from both those. Now let's say, why can't I use something in here? Well, let's use negative 2 for an example. If I use negative 2 plus 2, you're thinking to yourself already it's going to be 0, which is good. The absolute value is 0. Is 0 less than or greater than or equal to 1? And the answer is no. Okay. So again, if it's greater than or equal to, you're going to use an or. It can be either or. Okay. All right. Next one. I've got a greater than symbol. So I'm going to do t plus 6 is greater than 4, or t plus 6 is less than negative 4. Notice I flipped the inequality and made it the opposite number value. Okay? If I subtract 6 from both sides, I get negative 2. Subtract 6 from both sides, I get negative 10. So I have t is greater than negative 2, or t is less than negative 10. Okay. So from there, let's see here. Let's see, I can choose any value here. If I plug in a 0, 0 plus 6 is 6. The absolute value of 6 is 6. 6 is greater than 4. That works. Okay, hopefully that wasn't too confusing. Can't use 10 because it's an open circle, so I'll do like negative 12. Negative 12 plus 6 is a negative 6. The absolute value of negative 6 is 6, so 6 is greater than 4, also true. Okay. Now the reason why I chose not to write that out like I did the last one is this. What if you have a statement like this? X is greater than 4 or X is greater than 6. Okay. Well, if I go to graph that, let's say that 4 is right here, open circle heading that way, and I have 6 right here, open circle heading that way. Now, if I draw those down here, here's what we have. Okay? Since the answer can be in one or the other, I'm going to take all of this right here. Okay? So this right here is going to be my answer for the problem. So is 5 a possible answer here? And the answer is yes. Okay, I could answer my problem with the answer of 5. Okay. All right, now, what if I were to change that? Both of those are the same direction again. I'll use x is greater than 4 and x is greater than 6. Okay. Now again, we have those same issues. Open circle running that way, open circle running that way. Okay. So I'll put 5, 6, and 4. Okay. Now, because both open circles are headed the same direction, and the and is only where they overlap, both of these only start overlapping right here and head in this direction. So I'm going to go ahead and do something like this. That is the only answer. So is 5 an answer to this one down here now? And the answer is no. Okay. Is 6 an answer? No. Is 5.5 an answer? No. None of those are answers. But if I get to 7, okay, that would be a possible answer here. And if I go back to my original inequalities, if I plug in 6 up here, 6 is greater than 4, but 6 is not greater than 6. If I plug in 7, greater than 4, yes. 7 greater than 6, yes. Okay. All right. Whew. All right. So if I take a look up here, starting with number 1, again, this is a greater than, so it's an or statement. So either x is greater than 2 or x is less than negative 2. So as I look down here, I'm looking at, oh, there it is, less than negative 2, I like that. Greater than 2, I like that. B is my answer for number 1. Okay. On the next one, absolute value of x minus 2. Ooh, I'm going to take that absolute value off as I write out both inequalities here. So I'm going to do x minus 2 is less than or equal to 3. And because it's less than, I'm going to put an and down. So and x minus 2 is greater than or equal to negative 3. Okay. Now I'm going to add 2 to both sides. Okay. So we're looking at greater than or equal to negative 1 and less than or equal to 5. So let's see here. Okay, so sorry about that. I actually had to pause the video and teach the second half of the day, so and then come back after school. So hey, so taking a look here, remember it's the and, so x is greater than or equal to negative 1. I've got that right here, greater than or equal to, it's shaded, that's good. And less than or equal to 5. So again, just making sure we've got this down. The overlap is the part that actually counts. So as I go ahead and graph these two rays down, the parts that count would be from here to here, which is why C is going to be our answer for number 2. Okay. As we look at number 3, I'm going to do the exact same thing. Remember, less than, again, is an and. So I'm going to do x plus 1 is less than 4. And, now obviously process of elimination tells me this is A, but and x plus 1 is greater than negative 4. Okay. If I subtract 1 from both of those, and I know that x is going to be greater than -5 and less than 3. We have that there. Again, the overlap would look something like that, just from here to here. So we're good, okay? All right, now on to some story problems. We've got 2 different story problems here. And taking a look at the very first story problem, it says the weatherman predicted the temperature to be within 3 degrees of 52 degrees Fahrenheit, okay? And so as we think about this, if I was to put down a number line, let's go backwards on this. If I put 52 here, 3 degrees to the left would be 49 degrees, and 3 degrees to the right would be 55 degrees, okay? So the range of possibilities within 3 degrees, I'm going to color in those circles and then connect them. That's the range of possible answers there, okay? So as you think about it, my range from here, my deviation is 3 on both sides, okay? And that is the absolute value. That is what the absolute value is going to be. So my probability is going to be this. If it's within 3 degrees, I'm going to put less than or equal to, okay? It has to be contained. Remember, it's an and, all right? And so less than or equal to because it's an and. And this might seem a little bit weird at first, but I'm going to put x minus 52, okay, within that absolute value bracket. Now, if I write down both possibilities, okay, this is the end result right here goes here, and the range goes here. I'm going to go ahead and do this. X minus 52 is less than or equal to 3. And if I add 52 to both sides, I get x is less than or equal to 55 degrees. Okay? Well, that's that portion right there, less than or equal to. I am also going to go ahead and do greater than or equal to -3. If I add 52 again to that, I end up getting 49 degrees. Okay, so there's your greater than. You can start this way, like that. And then this one is the less than, like that. And then right here, from here to here, is the range, which is why we have that. So just a quick review. This is the end result. Okay, this is that middle number. Maybe I should say it's the middle number to the midpoint. And this is the range. So just keep that in mind. So as I look at the next one, Serena will make the B team if she scores within 8 points of the team average of 92. Okay, I'm assuming that's bowling. So what I'm going to do is this, x minus the midpoint, the average is 92. And within, so it's got to be within 8 points. Okay. So if I go ahead and do this, x minus 92 is less than or equal to 8. If I add 92 to both sides, I get 100. If I do x minus 92 is greater than or equal to 8, negative, sorry, about forgot that, -8. If I add 92 to both sides, x has to be greater than or equal to, let's see here, 84 degrees. Okay? So if I graph this, we're between, there's 84. Again, I've got a filled in circle heading that way. Here's 100. Filled in circle going that way. So my answer is from here to here. I'm going to put a filled in circle here and a filled in circle here and connect them. That's my range of possibilities. So she could score anywhere from 84 to 100 and make the B team. Okay? All right, I hope that made sense. I know that was fast. I know that was a lot of stuff, but hopefully you are good to go for the rest of the assignment. So we'll talk to you tomorrow.